Hi everyone, this is Mrs. V Chan. Welcome to my Form 2 Math lesson number 16. Today is 19th of May 2020. Alright, so today's topic is about trigonometric ratios of complementary angles. Now let me explain to you what is the meaning of complementary angles. Now here you have a right angle triangle, and let's say this is angle theta and this is angle phi. So what about if theta is 30 degrees? Then this angle phi will be 60, is that right? Okay, so we call this 30 and 60, so these two angles being complementary angles. Okay, so also, what about if this angle is 48? Then this angle will be 90 minus 48, so this is 42. Okay, and what about if this is 58, this angle? Then this angle will be 90 minus 58, and that will be 32. So we say this two angles being complementary angles. Okay, so here we have the conclusion, and then we can say that if the total of theta and phi is 90 degrees, then we say these two angles are complementary angles. Okay, next let's look at the value of sine 30. Sine 30 is equal to 1 over 2. And then how about cosine 60? And then cosine 60, for this 60, we can change that into 90 minus 30, which is 60. Okay, and the value for cosine 60 is also 1 over 2. So therefore, we can say that this sine 30 actually is same as cosine 90 minus 30, because both of them same as 1 over 2. So that we have this first identity in today's topic. And then we can change 30 to any angle. Let's say theta is equal to cosine 90 minus theta. Right, so this is the first identity we have in this topic. Okay, so next, how about cosine 30? Cosine 30 is same as root 3 over 2. And then now we look at sine 60. For this 60, we can change that into 90 minus 30. And the value for sine 60 is same as root 3 over 2. So you can see cosine 30, this one, is same as sine 90 minus 30. Therefore, we can get another identity saying that cosine 30 is the same as sine 90 minus 30. And this is the second identity we have in today's lesson. Okay, so finally we come to tangents. And what is the value of tangent 30? Tangent 30 is equal to 1 over root 3. And now the complementary angle for 30 is tangent 60. So therefore for this 60, it can be the same as 90 minus 30. And the value for 60 is root 3. Now we can come to have this identity and saying that tangent theta. Okay, look at this. This is 1 over root 3 and this is root 3. So this is the reciprocal of tangent 90 minus theta. Okay, so this is the third identity we have in this chapter. So when we have these two angles are complementary angles, and then we have three identities in this chapter. Okay, so let me rewrite these three identities again. So inside the box here. Okay, so now we have example 1, which is to express the following expressions in the form of tangent theta. And then this is part A. We are given cosine 35 over cosine 55. And look at this 35 and 55. Are these complementary angles? Let's take a look. What is the total of 35 plus 55? Yes, which is equal to 90. So we have these two complementary angles. So since we need to change this into tangent theta, so we do it step by step. I change the numerator on top. So 35 actually is same as cosine 90 minus 55. And then here remain this cosine 55 for denominator. And then what is cosine 90 minus 55? So here on top, if we have cosine 90 minus theta, that answer is equal to sine theta. So on top, I have sine 55, and here divided by cosine 55, so that the final answer will be tangent 55. So this is how we change that into tangent theta. Okay, so next we have this sine 10 over sine 80, and 10 plus 80 is 90, so these two are also complementary angles. So this time I keep this sine on top, and now I change sine here to 80. 80 is 90 minus 10, right? Agree with me? Okay, so therefore on top I have sine 10. And how about this sine 90 minus 10? Okay, so what is sine 90 minus theta, which will be equal to cosine theta? So this, I change that to cosine 10, therefore the answer is tangent 10, like that. Okay, so next we have example 2, and now we need to express each of the following in the form of cosine theta, and then now we are given sine 43 times tangent 47, and 43 plus 47 is equal to 90, so these two are also complementary angles. So here sine 43 is the same as sine 90 minus 47, and then now I have tangent 47, right? And what is sine 90 minus 47, which is equal to cosine 47, and now I can change tangent 47 into sine 47 over cosine 47. Therefore, this cosine 47 and this cosine 47 cancel out, and then my answer is sine 47. And what is sine 47? Sine 47 and 47 is same as 90 minus 43. So I can get my answer to change this sine into cosine. This is same as cosine 43. Okay. Okay, so next we have example 4. Now this time we have to find theta, however without using a calculator. Alright, so this is given that sine theta is equal to cosine 51. Alright, so can I make the left hand side and right hand side same as sine theta? I keep this as sine, and then now I can change this cosine, which is equal to 90 minus, okay, so 90 minus what is equal to 51, so that I have this 90 minus 51, which is 39. Therefore, keep going, sine theta, and now I can change this formula to what? Cosine theta minus this is equal to sine 39. Since this is sine and sine, I can make my conclusion and saying that theta is equal to 39. So this is how we find theta without using calculator. Okay, next we have example 3. Now here we don't use calculator, and now we need to find this expression, which is cosine square 49 plus cosine 41. And then also this is square. Alright, so this is the question. Now I'm going to change this cosine square, and 49 is same as 90 minus 41, because these two are complementary angles, and then plus is cosine square 41. And how about this? This is same as sine square 41, and then now plus cosine square 41. So what is my final answer? Because we always have sine square theta plus cosine square theta equals to 1, so here which is equals to 1. Okay, now in this example I changed the first term into another angle. So what about if I change the other one? Let's say, do we also get the same answer? So I just rewrite the question, and then plus cosine square 41. Okay, this time let me change this one. So keep this 49 plus. Okay, and how about this 41 is same as 90 minus 49. Is that right? And here I have cosine square 49 degree plus. So how about this? So cosine square 90 minus theta, which is same as sine square theta, which is 49. So sine square theta plus cosine square theta, so my answer is also same as 1. Therefore, you can see it doesn't matter you change the first term or you change the second term, you also get the same answer. Okay, next, how about this one? Cosine 12 degree over tangent 78 and then minus cosine 78. So 12 and 78 also, they are complementary angles. Now, I'm going to change this 12 into 78 so that I have this cosine 12 is equal to 90 minus 78. Right, so that I get this tangent 78 minus cosine 78. Okay, so therefore for this on top, which is sine 78. And now I'm going to change this 1 over tangent 78 divided by, I need to flip over this into cosine 78 over sine 78, and then this is cosine 78. And now this sine 78 and this cancel out. So what is the final answer for cosine 78 minus cosine 78, which is equal to 0. Okay, so sometimes you can change the subjects in this way. Cosine theta is same as sine 90 minus theta, so that we change the subject in this way, you will find it very useful as well. Now we come to point C here. We need to evaluate this 2 tangent theta over cosine 90 minus theta and then minus 1 over sine 90 minus theta. Alright, so keep this on top. Okay, and now I can change this. Cosine 90 minus theta is same as sine theta and then minus 1 over, how about this sine? Sine 90 minus theta is same as cosine theta. Okay, we just do it step by step. Okay, and how about this tangent theta? So 2 over sine theta, and I'm going to split this tangent theta into sine theta over cosine theta, and here is 1 minus 1 over cosine theta, and now I have sine theta cancel out, so what's left? So 2 over cosine theta minus 1 cosine theta. So since I already have the same denominator, I can combine them together. So this is cosine theta, and what is 2 minus 1 is equal to 1. Alright, so this is it. If you change the subject for this identity, you will find it very useful as well. Okay, next, how do we change this tangent 15 times sine 75 into cosine theta? Now this time, what about we start with tangent 15? Tangent 15 is same as, this 15 is same as 90 minus 75. And then this is sine 75, is that right? Okay, and then for this, tangent 90 minus theta is same as 1 over tangent 75. And then I have sine 75. So therefore for this 1 over tangent 75, I need to flip over sine theta over cosine theta into this. Cosine 75 over sine 75 and then times sine 75. Okay, and this sine 75 cancel out so that I can get my final answer as cosine 75. Okay, next, we also need to find theta without using calculator, and this is the question. Tangent 66 is equal to 1 over tangent theta, and now I want to make my subject on the left hand side, so I flip this, I change left hand side and right hand side in this way. Alright, and then I keep this 1 over tangent theta, and how about this 66? 66 is equal to 90 minus something. Minus what? So 90 minus 66, which is 24. So that 1 over tangent theta is equal to 1 over tangent 24, right? Okay, now I can make my conclusion because everything's same, so that my conclusion can be theta is same as 24 degree. All right? Okay, so how about this one? Tangent to theta is the same as 1 over tangent theta. To find theta, now I can change this tangent to theta if I put this 1 over, and that will be tangent 90 minus 2 theta on the left hand side, and then on the right hand side I have this. So therefore I can make my conclusion and say that this one is equal to theta. So 90 minus 2 theta is equal to theta. Okay, so this is negative 2 theta and this is theta. I don't want any negative thing, so I can just flip over this left hand side and right hand side. You okay? So if I move this minus 2 theta on the right hand side to the left hand side, so that will be plus 2 theta and then 1 theta here, so I have 3 theta is equal to 90 degree. Therefore, what is 1 theta? So 90 divided by 3, so that I get 34 theta in this way. Okay, since I still have space on this page, let me show you another example. Here it is. Cosine theta plus 28 is same as sine 28. Okay, now I am going to keep this left hand side. And then now I want to change this sine 28 into cosine. So that will be 90 minus 28, right? Okay, so that cosine 90 minus theta is same as sine theta. So this is how I change it. So now I have cosine and cosine, so that I can simply make my conclusion and saying that theta plus 28 is same as 90 minus 28. And now I have only one subject, one unknown here, which is theta. Alright, so what is the value for theta? That would be 90 minus 28, and this plus 28 on the left hand side move to the right hand side minus another 28. So my final answer for theta will be equal to 34. Okay, so how about this one? Sine 3 theta equals to cosine 2 theta. So how do we find theta? Alright, so how can we change that? So remember, this cosine 2 theta actually is same as sine 90 minus the whole thing. Okay, so I can say that this is 3 theta on the left hand side and 90 minus 2 theta, and this is also sine and sine. I can make my conclusion and saying that 3 theta is equal to 90 minus 2 theta, right? I just solve equation and move this 2 theta to the left hand side. So plus 3 plus 2 is 5 theta equals to 90. Therefore, I have my theta is 90 divided by 5. So the answer is 18 degree. Alright. Okay, now we come to the final example in today's lesson. Now we need to prove these identities. Here we are given identity, which is saying that the left hand side is exactly same as the right hand side. Now we need to prove. So remember, whenever we prove, we must separate the left hand side and right hand side. Now I start with the question on the left hand side. So on the left hand side, we have this. Okay, so remember what is sine 90 minus theta, which is cosine theta over tangent theta, right? And then therefore I have this sine theta cosine theta on top times. Okay, look at this tangent theta. This is divided by tangent theta. I flip over this into cosine theta over sine theta. Okay, so what's next? Do we have things to cancel out? This is sine theta no more. So therefore I have this cosine theta times cosine theta, which is cosine square theta. And what is cosine square theta? Which is same as 1 minus sine square theta. So look at this. It is exactly same as the right hand side. So I have to move my equal sign. Okay, here, therefore, it is an identity. Okay, now we have the final question. So to prove this identity, okay, what is the left hand side? So that I will have the left hand side on top, cosine square theta, and then what is cosine 90 minus theta, which is same as sine theta. All right, I stop here for left hand side, and then I go to the right hand side. Okay, then I have tangent 90 minus theta, and then this is sine 90 minus theta. Is that right? Okay, and what is tangent 90 minus theta, which is same as tangent 1 over tangent theta, and also times this sine 90 minus theta. which is same as cosine theta. Okay, almost there. And then 1 over sine theta, again, I split this sine theta over cosine theta in this way. And then times cosine theta, we just do it step by step. Therefore, the final answer, cosine theta times cosine theta, I get cosine square theta on top and over sine theta. So you can see the left hand side will have this and right hand side will have this, so which is exactly same as the left hand side, and the conclusion is therefore it is an identity. Okay, so that's all about today's lesson. We have the identities for complementary angles. So thank you for watching my video. I'll see you next time. Bye bye.